Okay, can you see my slides here? Can you see the slides?
Yes.
Yes.
Okay, good. All right, so that's this chapter is on discrete probability distribution. Actually, there are two probability distribution. One is discrete, another one is normal or continuous. Okay, so that one you will learn next week. So this week is just on discrete, and your midterm will be until this topic. Okay, so from topic 1, chapter 1 until chapter 6. Now is week 5, right? So it's from basically from the first week until this one. Okay, today's topic, your midterm. The rest will be in your final. Okay, so let's move on. All right, this is just some of the basic concept. The first one on random variable. So random variable is basically just the numerical description of the outcome of experiment. So we know what is the outcome of the experiment, right? Last week you learned about experiment, what is experiment, what is outcome. So this one is just the way you describe the outcome in numerical form. Okay, that is random variable. So random variable can be divided into two. One is discrete, another one is continuous. Okay, so what is discrete? Discrete when you have a finite number of values. And continuous, you have interval or collection of interval. So for example, like this one, okay, the first one here for the discrete. Okay, so for the first one, for discrete here, it can be, for example, 1, 2, 3, 4, and so on. Or it can also be, for example, 1.5, okay, 2.5, 3.5, something like that. It's discrete. But continuous here, you can have, it's continuous. For example, you can have 1, and then 1.1, 1.111, 1.1111. Okay, that one is continuous. This one just, is a, it's different. It's slightly different from round number. Round number is just this one. Okay, so don't get confused. This is round number, but discrete you don't have you don't have like 1.11111. Okay, that one is just like this one only. This one is discrete. Okay, the continuous is like this. That one. Okay, it's just continue. Okay, so I hope you can see the difference. All right, then for discrete probability distribution. This is how over the values of a random variable. Okay, we know what is probability distribution. This one also you learned last week on probability chapter. Okay, in probability chapter, and even the word distribution I mentioned many times last week in the previous topics. When we mentioned about distribution means you have something like a table, right? To show how your data spread. Okay, so the probability distribution for a random variable is basically to describe how probabilities are distributed over the values of the random variable. Okay, it's similar, just that this one for random variable. Okay, and the probability is given by this notation, Px. Okay, and the formula also similar to the formula you used in the previous topic. Okay, for the probability, later we'll see the formula. Okay, these are the condition for the discrete probability distribution. Also the same as the previous one. We know that for probability values is always between 0 and 1. Alright? This is your probability value. Okay. So it can be as low, the lowest would be 0, the highest would be 1. It cannot be more than 1, it cannot be less than 0, it cannot be negative. Okay, but it can be any value in between 0.5, 0.7, for example. Okay. So just the same here. Okay, the condition for the discrete probability distribution just the same as a normal probability. We know the total must be 1. The sum of all probability must be 1. Okay, and for this one also we can use table graph equation to describe the discrete probability distribution. Normally we just use table only. Okay, like last time also we use table to display the probability distribution. Okay, so how do you find discrete probability distribution? Again, it's similar to how you find the frequency distribution, the relative distribution last time. It's very similar to that. Okay, so these are just a step. Later we have the example. So first we make a frequency distribution for the possible outcome. Okay, if you forgot about this one, frequency distribution, then I advise you to go back to the previous chapters. Okay, they all linked. All the chapters are linked one to another. Find the sum of the frequencies. Okay, sum of the frequencies, then the total, how many frequencies in total. Find the probability of each possible outcome. So how do we find the probability? You divide the frequency, this one, number 1 here. Oops. You divide number 1 by number 2. So dividing its frequency by the sum of the frequency. So what is the frequency? For example, your frequency is only 2 out of 10. Total is 10. So 2 over 10. That is your probability. Check that each probability is between 0 and 1. Okay, to confirm that your value is valid or logic. Okay, if you get more than 1 or less than 0, then something is wrong. Okay, you need to check because probability must be between 0 and 1 inclusive. Okay, now let's look at the example here. So let's say our experiment is to toss 2 coins. Okay, last week we have example toss a coin, right? When you toss a coin, you either get head or tail. Okay, now in this case, we want to toss 2 coins. So another one also head or tail. So we have two coins here. Okay. And our event, what we interested to look at is the number of heads. How many heads appear when you toss a coin? Okay, so this is the possible outcome. Let's say the first coin. This is the first one here. This one is the first coin. This one is the second coin. Okay, and of course they are independent of each other, right? They are two different coins. So when you toss a coin, let's see first you get tail. You toss the second coin, you get tail again. Okay, another possible outcome. First you get tail. Okay, like this one. First you get tail. Second one you get head. The third one, you maybe get head first, this one, and the second one is tail. Okay, or first time you get head, not first time. First coin you get head, second coin also head. Okay, so only these 4 possible outcomes. You don't have any other outcomes. Right, only this. Okay, so now the question asks you for the number of heads. So we can see how many heads appear here. Okay, so there are either no heads at all. For example, like this one, the first outcome here, or only tail. Both coins give us tail. Okay, so the value is 0 for the number of heads. So there is 0 number of heads. Okay, there is no head. The second one here, for this part here, we can see that the second one, we have 1 head out of 2 outcome. The third one also 1 head out of 2 outcome. So only 1, right? 1 head. But it appears 2 times. Okay, for this case, when you get 1 head, 1 tail, it appears 2 times, right? These two. Okay, so this one, 1 head, you get 2 times out of 4 times. Okay, this 2 out of 1, 2, 3, 4 outcomes here. 2 out of 4. And the third one, again, our focus is number of heads. So you get 2 heads. Okay, first coin head, second coin also head. So this outcome only appear 1, right? So that's why for the number of heads equal to 2 because it's head and head here. So it appear only 1 out of 4 outcomes. Okay, so 1 over 4. Okay, so this is the one mentioned earlier, this one. Okay, the sum of the frequencies are 4. The probability is the frequency divided by the sum. So this one, yeah. The sum and the frequency is 1 time out of 4. The frequency is 2 out of 4. The frequency is 1 out of 4. Okay, which we can change to decimal like this because again, probability normally we write in decimal. So it's 0.25, 0.5, 0.25. So obviously this is discrete, right? It's not 0.255555. Okay, that one is continuous. This one just 0.25, stop. 0.5, 0.25. Okay, so it's discrete. If you draw the graph, it's like this. For outcome 0, 1, 2, okay, we have 3 outcomes here. So the first one we have 0.25, second one we have 0.5, the third one 0.25. Okay, so just 1 here, 1 bar here, 1 bar here. Okay, so it is discrete. Okay, so this is how we come up with the probability distribution. And below here, what do you call this one? Remember what you call this? What is this? The below part here. Anyone can recall what do we call this when we draw like this?
Diagram.
Tree diagram. Okay, tree diagram. So, because as you can see, it's like a branch of tree. So the first coin, this is actually represent the first coin. Okay, this one is the first coin, and this one is the second coin. Okay, so first coin you get either head or tail. Second coin again you get either head or tail, head or tail. Okay, so you get the same outcome. It's similar. It's just the other way of writing it. This one like you draw. This one like you draw also, but in this form. And you can also find the probability here. Okay, from this one. This one maybe you can see you have to put it in a table like this. This one actually you can write the probability. Okay, so for example here, how do we get this half and half? To get a head, the probability is 1/2, right? To get another head, the probability for the second coin, probability also 1/2. So 1/2 times 1/2, you get 1/4. And in fact, it's the same for all. Okay, all you get 1/2, 1/2. So just the same. And if you want to come up with this table from here, then again, we want to see how many number of heads. So it's either this one 2 heads, this one 1 head, okay, this one 1, and this one 0 head. So again, you can just tabulate like this 0, 1, 2. So 0 is only 1, right? 1 outcome. So 1/4 only, 0.25. This one, for case of 1 here, so you have to add these two. Okay, so 1/4 plus 1/4 is 2/4. 2/4 is 0.5. And the third one is 1/4 as well. So just another way. And last time also you learned there are two, right, for the multiplication properties. This the multiplication properties. This one is considered special multiplication rule or general multiplication rule. What do you think? This one here is a special multiplication rule or general multiplication rule. Last week you learned already. Well, last week for the probability you have addition rule is either special or general. Multiplication also you have special and general. Right. So this one, what do you think? This one, this is obviously multiplication rule. You multiply here, but is it general or special?
Special.
Special. Okay, so this is special multiplication rule. Is for independent event. Okay, forgot, please refer back to the notes here. Independent event. Independent, why independent? Because when you toss the first coin, it doesn't affect the second coin. When you toss the second one, it doesn't affect the first one. Right, there are two independent coins. Okay, so for this one, is a special multiplication rule, and this is also what we call the joint probabilities. Okay, this is actually the joint probabilities. Okay, joint probabilities means, for example, probability of head and head. The first one here, probability head and head. Okay, so you multiply half times half, you get 1/4. Probability head and tail. Probability tail and tail. Okay, so we just multiply like this, you get the value here. Okay, so next one. So from this discrete, we can also find the mean and also the variance and standard deviation. Okay, so how do you find the mean, or in this case we call it expected value, but they are actually the same. Okay, mean and expected value the same. Okay, so the formula is mu equal to EX. E is for the expected. Okay, X is your event. So EX equal to summation of SI PSI. Okay, so if we refer back to this one, we have X here, we have the probability, the P. Okay, or this one, just the same. Okay, so we have this. This is our SI. Okay, and this is our PSI. Okay, the formula here. So to get the expected value. For example here, okay, again, it depends on what event you want, what are you interested to look at. Like the previous one, we just want to look at the number of heads. Okay, it can be different. It can be, for example, number of tails. Okay, in this case, only two lah, either head or tail. Okay, but if you have, for example, if you roll a die, then you have 6 outcome, right? So possibility you want to find, for example, number of 2, number of 3, number of 4, number of 5. Okay, so there are more outcomes there. In this case, because coin only give you 2 outcome, head or tail, then the question might be either find the number of heads or number of tail. That's all. Okay, you don't have any other event for this case. So let's say we have this and we want to find the expected value, okay, or the mean here. So this is a formula, expected value or the mean. Okay, we use this mu here. So how do we find? The x, which is your data here, 0, 1, 2, and your PSI, your probability. So each of this is, as you can see, I from 1 to n. In this case, for this case, it's actually I from 1, your n is 3. Right, you have 3 outcome, 1, 2, 3 here. Okay. So SI, PSI. Okay, so this is your S1, PS1, S2, PS2, S3, PS3. You have to add all. Okay, so S1, 0, PS1 is 0.25. So you multiply this. Multiply this plus with 1 times this. Plus with 2 times this. Okay, so then you get a total. Like this, 0 times 0.25 plus 1 times 0.5 plus 2 times 0.25. So you get 1. So again, don't get confused with probability. This is expected value, the mean. There is no limit for the mean. It can be even 100, it can be 1,000. It depends on your values here. Okay. Okay, so if you can get the mean, you can also find the variance and also standard deviation. And we already know that variance and standard deviation, they are related, right? Standard deviation is just the square root of the variance. Okay, so this one is just the square root of the variance. Here, square root of the variance. So to get the variance, before that variance, it shows you the variability in the values of the random variable. So how your values spread, distributed, yeah, the variability of the values. Okay, so this is the formula. Variance we use sigma square. Standard deviation we just have sigma because we square root. So formula is SI minus EX square PSI. Okay, again, it looks complicated, but actually all the values you have already. The 0, so we have 0.25, 0.5, 0.25 just now, right? We have 3 values. ESI is how you find the in the previous slide. This one, ESI is 1 in this case. Okay, so we have all the values. You just have to substitute only. Okay, so for example here, okay, again, let's look at the same event, number of hits, and we want to find the standard deviation straight away. Okay, so standard deviation straight away, you can put the square root to the variance. This many times. Okay, so SI minus ES square PI. Our data just now is SMPS. Okay, so we have the 0, 1, 2 just now. I think this one, if I'm not mistaken, 0.25, 0.5, 0.25, right? Okay, so you just substitute your SI. The first one is 0. 0, we know that the mean, the average, the expected value is 1 just now. So 0, this one 0 minus 1 square times PSI, the first one 0.25. Okay, plus is summation, yeah, so you have to plus 1. Okay, this one 1 minus your mean, so 1 minus 1 square times 0.5 plus 2 minus 1 square times 0.25. Okay, then you get the answer. Square root and you get the answer. So it's quite straightforward actually. The same if the question asks for variance, then you just square the value. Okay, next one we have covariance. So covariance, when you see the word co here, means you have more than one actually, more than one variable. Okay. So more than one. So this one is to see or to measure how much two variables, for example, we just call it x and y, change together. Okay, so we have two variables x and y, and we want to see or to measure how they change together, how much they change together. So again, the formula maybe looks a bit tedious, but actually we have all the values. So we have SI, we have EX you can find, we have Y, YI, because remember we have two variables here. Just now we only have SI and PSI, right? Okay, we have all these. Another one we have YI and PYI, because we have two variables now. So we have all the values already here. And of course, from here you can find the expected value. You can find the expected value, EX. This one also you can find EY, the expected value for this data. Okay, so we have SI minus EX. Okay, each of these minus your mean, and then multiply with YI minus EY. So each of these minus your mean, and then multiply with PSIYI. Okay, the probability of this one. Okay, the probability of this one, we have to find out. Okay, let's look at this. See, we have example here. There's a note here below here that if you get a positive value, that shows a positive relationship. If you get negative value for this, when you calculate the covariance here, sigma SY here, it shows us the negative relationship. Okay, and I hope by now you understand what is positive relationship, negative relationship. Like the one I draw last time, positive relationship like this, negative relationship like this. Okay. Okay, example here. So let's say we have this investment return. Okay, we have return per $1,000 for two types of investment. So we are given the PSI. In this case, you don't have to calculate. Okay, the probability is already given. 0.2, 0.5, 0.3. I think most of the question also normally is given. Okay, the formula of course more tedious. Economic condition, we have three here: recession, stable, and also expanding economy. And we have two investment X and Y. So investment X is more passive. Investment Y is aggressive. Okay. You can also see from the values here. This one is more passive than is passive. This one is aggressive. Okay, so of course, from this you can find the expected value. Right, you can find the expected value for X. You can also find the expected value for Y. Okay. Using the formula that you've seen earlier. So what is the formula just now? For the expected value, we have this. Summation SI PSI. So this one. Summation SI PSI. Okay, so just the same with this one. This one is summation YI PYI. Actually, if you know how to use it, you don't have to write the formula. You can straight away find the value. Okay, this one just want to show, to recall back what's the formula just now. So how do we find this? EX is each of your data, is each of your X, which is here, multiply with the probability. Okay, so each of these, let me check first. Okay, that's the formula. Oh, okay. So we have this. This one. Covariance, that's correct. Okay, so the probability is this one. Because there are two variables here. So that is actually the probability. So This one is actually, instead of we write like this, is actually this probability, PSIYI here. Okay, it's only one probability here. So this probability is for both X and also Y. Okay, so you can see here negative 25 times 0.2 plus 50 times 0.5 times, plus 100 times 0.3. Okay, the first one here for EX. So we get 50. While for the fund Y, okay, to get the expected value for fund Y is each of the Y, this value, each of this multiply with this one. Okay, so this PYI is actually PSYYI for both variables, so probability for both variables. Okay, so it's negative 200. If you have negative, put negative. Negative 200 times 0.2 plus 60 times 0.5 plus 350 times 0.3. Okay, so you get 95. So from here, we can see that the return is lower than the return for investment Y, right? Investment X only give you return of, let's say here, $50, and investment Y give you return of $95. Logically, which one is better, X or Y? Which one do you think is better, X or Y?
Why?
Y, okay. Why? Why?
Because more money.
The return is higher, right? So logically, if we look at these values between investment X and Y, okay, investment X only give you return of 50, while this one 95 is almost double. So if you look at only this number, then investment Y is actually better, okay, because it give you almost double return, okay, per 1,000 invested. Okay, now let's now find the standard deviation. We want to see how the variability of the data itself, the variability of the fund X and Y. So to find the standard deviation, again, just the same formula as the previous one. Okay, this formula just now. This one. Okay, your data here. So we have this formula. Let's put here first. Okay, so that's the formula for the standard deviation. Summation of each of your data minus your mean, which already we find just now, right? Our mean just now is 50 and 95. Okay, so our EX is 50 and our EY is 95 just now. Okay, so each of your data here minus your mean square times your probability, which is here. Okay, so the first one, negative 25 minus your mean 50 square times 0.2. Okay, so we have this plus second data 50 minus your mean 50, mean of X, yeah, 50 square times 0.5. Plus the third data here 100 minus 50, your mean, times 0.3. Okay, square times 0.3. And then you square root because this is standard deviation. So you get 43.3. The second one for Y, standard deviation for Y, just the same. Each of this data minus your mean, which is 95, square, in the formula we have square here, times the probability. Okay, each of these. So negative 200 minus 95 times 0.2. 200 minus 95 square times 0.2. 60, the second one, minus 95 square times 0.5 here. 350 minus 95 square times 0.3. Okay, so we get this. So again, if you compare this between these two conditions for the X and Y, obviously the Y one here is higher, right here. Okay, so again, which one is actually better, X or Y, in terms of standard deviation? Just in terms of standard deviation here, which one is better? Anyone? Any idea which one is better? The X or Y?
X
Has lower. Sorry?
X.
X, okay, because of the smaller standard deviation. Okay, if you can recall, there's one tutorial on the battery life last time, right? Ever last or what? I can't remember. Similar to this, the standard deviation, the highest standard deviation, can't remember endurance or what, can't remember the name. That one is worse than the other one because it has higher standard deviation. So like similar to this one, okay, you can see here, even though the fund Y has higher return, as we can see previously, just now in the previous slide, but then the standard deviation is high. So it's subject to much more variability. The variability is high, the spread of the data is higher, and the probability of loss also higher. Okay, because of the high standard deviation here. So we prefer the small standard deviation. Okay, so it won't deviate much from your mean. Remember, this is your mean. So you have like one standard deviation, right? We have two standard deviation, three standard deviation. So we don't want the value to be far from this mean here. Okay, so one for the X is just here. The value is between this and this only within this range. But then for the Y, the range is much bigger, right? So there is a possibility of loss on this side here. Okay, that's what it means. So there are pros and cons actually between the two. Okay, next slide, we want to find the covariance. Okay, since we have two variables, so we can find covariance. So covariance, again, the formula given is this. So that's the formula for covariance. Yeah. So summation of each of your data X minus the mean. Again, we know the mean already. Mean for the X is 50 just now. Mean for the Y is 95. Okay, so each of your data here minus 50. And then if yi minus ey, so each of this data minus 95, multiply with psi yi here, probability. Okay, so negative 25 minus your mean 50 times with negative 200 minus your mean 95, okay, times 0.2 probability. Okay, summation. So you have to plus for all three here. Okay, so 50 minus, the mean is 50, 60 minus 95 times 0.5. The last one here we have 100 minus the mean 50. The y here 350 minus the mean of y 95 times the probability 0.3. Okay, so we get 8250. Again, there is no limit for this number. There is no range or interval for this number. It can be any number. So since the variance is large and positive, so we know that there is a positive relationship between these two investments. Okay, which means that they will likely rise and fall together. Okay, if this one rise, this one also rise. Positive relationship between the two. Is. Okay, for example, this is X, this is 1. Okay, so that's just a similar summary. The aggressive fund has higher expected return, which is 95 just now, but much more risk. So the expected return for 195 higher than the expected return for the X, which is 50, but the standard deviation for the Y is higher than this one. Okay, so we have higher risk. And covariance here indicate that the two investments are positively related and we vary in the same direction. Okay, before we move further, any question? Do you have any question? Am I too fast? Russ, are you done? Okay, Ken. Hopefully all of you are there in front. Because I made effort despite I had to cancel my yesterday morning class because I really cannot speak because of the blocked nose here. But for today's class, I'm thinking, okay, I'll just do it. So I hope you make effort also to listen. Okay, so don't just depend on the recording. All right, so under probability distribution, we have discrete and continuous. Okay, so today we are just looking at these two. Okay, for the other discrete, we have two, binomial and Poisson. Okay, this one we go through next week. Okay, so the first one, we go to the first one first, binomial. Oops. Okay, so binomial, what is binomial? Binomial, you have n identical trials. Okay, n can be 10, 20, 500, 1,000, how many trials? For example, if you flip a coin, right? If you flip a coin, you baling duit. So how many times you flip the coin? Okay, it can be 1,000 times, it can be only 3 times, only 5 times. Okay, so that is the trials. Each trial has only two possible outcomes, success and failure. Okay, so each of these trial only has two outcomes only. That's why the name is binomial, bicycle, only two, right? So when we mention binary, only 0 and 1. Okay, bi here means only two. So only two possible outcome. So for example, we have success, failure, yes, no, what else? Like accept, reject. Okay, so only two outcomes. The probability of the two outcomes remain constant for each trial. The probability must be remain constant, always the same number. The probability of a success denoted by P does not change from trial to trial. Again, just like when you toss a coin, the probability is always half, right? You will also see from the earlier example for the head and tail just now. Okay, so it's half, 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 half. If you roll a die, it's always 1/6, 1/6, 1/6. Okay, so even 1,000 times, 10,000 times, it's always 1/6. Okay, that is the probability of getting a number. Okay, the trials are independent. Okay, the outcome of one observation doesn't affect the outcome of the other. Okay, similar to the toast coin just now. Okay, when you toast two coin, they are independent. Okay, so our interest is the number of successes. Okay, in the n trials. So we use X to denote the number of successes in the n trial. Okay, so we have n trial. You see the notation we use here. We have n trials and we use X for the number of successes. So we have X and n here. Okay, so these are just some of the possible outcome. For example, for manufacturing plant, we have either defective or acceptable. Marketing research response, for example, we have either yes, no, yes, I will buy, no, I will not buy. Job applicants, we have either accept or reject. Okay, the applicant. So in general, we just call it success and failure. Okay. Okay, so remember just now we have S and N, right? N is the number of successes that we want. N is the number of trial. Okay, that is S and N. So that's the formula. I'm sure you have seen this one before, right? In secondary school. Okay, this formula, we have learned this. I think in modern maths, if I'm not mistaken. This part normally is written like this. Yeah? So, okay, NCX. Small n here, S, small s here. Okay, so it's the same as this one. Just notation only, the different way of writing it. Okay, and this is actually the formula, n factorial over x factorial, n minus x factorial. So what is factorial? You can press calculator, that's the easiest. But factorial basically means, for example, if I use number, let's say 5 factorial, then this is 5 times 4 times 3 times 2 times 1. That is 5 factorial. Okay, with 3 factorial, then 3 times 2 times 1. Sorry. Okay, so that is factorial. Okay, but again, you don't have to calculate manually, just use calculator for this. Okay, let's move on. Okay, just a formula here. to find the probability for the binomial, okay, this P x equal to this one. This is just the formula. So we have example. Okay, so that's formula. Just put in box. So we have this formula here. To get this probability x equal to any number, then the formula is NCX Px 1 minus Pn minus x. Okay, P is the probability. Okay, the NCX here is the one that you have seen just now in the previous example here. Okay, this is NCX. So the NCX itself is, just now we have the formula which is n factorial, x factorial, n minus x factorial. Okay, this one in the previous slide. Okay, so n sample size, number of trials, P is the probability. So 1 minus P is, sometimes the formula use Q here, which is actually 1 minus P. Okay, sometimes you can see that it's actually NCX P, X, Q, and minus X, just the same. Okay, after they change this to Q, it's actually just the same. Okay, for example, firm A bought 10 computers, and if the probability of purchasing a defective computer is 0.8, what is the probability of purchasing 2 defective computers? If firm A bought 10 computers, that is your number of trials. We have N here. Now, the probability of purchasing a defective computer is 0.8. That is the probability. The probability is 0.8 here. What is the probability of purchasing 2 defective computer? Okay, you cannot simply multiply by 2. Okay, you see a defective is 0.8, so 2 defective 0.8 times 2, that's wrong. Okay, it's not like that. So how do you find probability of purchasing 2? Then P x equal to 2. Okay, so we write like this, P x equal to 2. X here means the probability of purchasing 2 defective computer. Okay, purchasing defective computer equal to 2, so 2 defective computer. So formula is NCX, so if you substitute this, N is 10, X here is 2, okay, probability is 0.8, X here is 2, 1 minus 0.08, N minus X, so 10 minus 2. Okay, that's the same, substitute only the formula. Okay, then use calculator. I hope you know how to get this from the calculator. If you don't know, maybe you can, the easiest is Google. Now you can just Google. If we have physical class, you can ask, but that's too late already. Okay, so maybe you can Google or ask your friend. Okay, then you get answer. That is the probability of purchasing 2 defective. So you see, it's not simply this 1 multiplied by 2. Okay, another example. What is the probability of 1 success in 5 observation if the probability is 0.1? Okay, so the question asks for probability of 1 success. Okay, we just want 1. So basically the question asks us to find P x equal to 1. Okay, 1 success in 5 observation. So this 5 is our N. N equal to 5. Okay, and trials. And the probability is this. So this is P 0.1. So we have x1, x equal to 1, and equal to 5, P 0.1. Okay, again, you just substitute in the formula just now. So formula just now is NCX, Px, 1 minus P, n minus x. Okay, so we know n is 5, or we can use like this. So 5 factorial over 1 factorial, 5 minus 1 factorial, n minus x here just now. P is 0.1, x is 1, means x is 1. 1 minus P, which is 0.1, 5 minus 1. Okay, we have all the values, you just have to substitute only. So straight away from calculator, using calculator, you can get the answer from here. Okay, which is 0.32805. Okay, questions we have here. I have another one here. Suppose the probability of purchasing a defective computer is 0.02. Okay, now the probability is changed already. Okay, the probability is 0.02. So P 0.02. What is the probability of purchasing two defective, you see this one is defective. This one also must be defective. Must be the same. If not the same, then you can find the other value. So purchasing a defective computer probability is 0.02. What is the probability of purchasing two defective computer? Be in here in a lot of 10. Okay, what is the probability of using two defective computer in a lot of 10? Not is the lot, that's wrong. In a lot of 10. Okay, so find our n is 10. So find E x equal to 2 defective. Okay, so if I rewrite again, in case it's hard for you to see from here. So the formula is NCX Px 1 minus P and minus X. Okay, formula is given in the previous slide. This one. This one. Okay, NCX Px 1 minus P and minus X. NCX we know is this one. Okay, so I will write again. NCX here is 10 factorial. Oh, sorry, maybe I should write this one first. Substitute the value first. That's just the formula. Okay, that's just a general formula. So ours now is 2. So our n is 10. 10 C2. Okay. Our P is 0.02. X is 2. Right. 1 minus P, 1 minus 0.02. N is 10 minus 2. Okay. So again, from here, you can just use calculator. Actually, you don't really have to do like this. Okay, if you can use calculator, just use it. Especially this one in midterm. In midterm, you have to remember that is the method of speed actually. It is not about the steps because midterm will be objective. The midterm is what? 30%. I think 30%, right? Because presentation is 20. Midterm 30, yeah. So 30 question. 30%, 30 question. So I can't remember how long duration. I have to check again. Either sure 1.5 hour or 2 hour. I'm not sure. I have to check. Okay, so it's a matter of time, which is speed. So we don't care how you calculate, as long as you get the answer. Okay, so if you can use calculator straight away, just use. You don't have to expand like this. Okay, so this one, if I expand, it's actually 10 factorial, 2 factorial. Okay, and then for this one, yeah, 10C2 here. So 10 minus 2 factorial. Okay, then the rest just the same. Times 0.02. Sorry, 2 times 0.1 minus this one is 0.0 is 0.98, right? Is it correct? 0.98. Okay, so use calculator straight away, you get the answer. This one. 0.01531. Please check whether it's correct or not. Can't remember. Okay. Any question? Is it okay?
Okay.
Okay, thank you.
Okay, doctor.
All right. Okay, so the same for this one. For binomial, you can find the mean and variance as well as standard deviation. So the mean is NP, or the expected value is NP. N is the number of trials, P is the probability. Okay, because in this binomial, for binomial topic, you only have N, you have P, you have S. You only have this variable only for binomial. NPS. N is the number of trials, P probability, S is what you want to find. Okay, the success, the probability of the success, for example. Okay, this defective, the event. So to find the mean is just N times P, these two. To find the standard deviation is NPQ. Okay, some would they write as NPQ, where Q is 1 minus P. It's the same. Okay, P times 1 minus P. So to get the standard deviation, you just square root. Example, Evans is concerned about a low retention rate for employees. In recent years, management has seen a turnover of 10% of the hourly employees annually. Thus, for any hourly employee chosen at random, management estimate a probability of 0.1 that the person will not be with the company next year. Okay, so you see the sentence here. We know the turnover is 10%, which actually is 0.1. Okay, thus, for any hourly employee chosen, the management estimate a probability of 0.1. The person will not be with the company, which means that it's the same meaning here, right? Turnover. Okay, turnover rate 0.1 just now. Okay, so the probability is 0.1. They're not with the company. So choosing 3 hourly employees at random. This is your end because you choose 3 trials. Okay. What is the probability that one of them will leave the company? Okay, so basically the question asks you to find P x equal to 1. Right. X here is for the probability of the employee will leave the company. Okay, that is X. The P here is the probability that the employee will leave the company. Okay, all the same case here, all leave the company. Okay, not retain. So find this one. It should be easy. We have all the value. We have n equal to 3. We know P 0.1. So just find this one. You can just use the previous formula straight away. Find also the mean and standard deviation. Okay, so as you can see here, we want to find P as equal to 1. We know the P is 0.1. Probability and is 3 as is 1. So just substitute. So that's the formula just now. N factorial. N is 3. So 3 factorial. X is 1. So 1 factorial. N minus X is 3 minus 1 factorial. P here is the probability, which is 0.1. So 0.1 power of X. X is 1. So power of 1. 1 minus P. So 1 minus 0.1. N minus X. N is 3 minus X is 1. So 3 minus 1. Okay, straight away, use calculator, you get 0.243. Okay, so this is the probability that one of the employees will leave the company this year. So 0.243. 4.3% chances that the employee will leave the company. It's quite high actually, 24%. Okay, then we can also find the mean or the expected value. So the formula just now is NP, for the variance is NPQ. So NP, we know N is 3, probability is 0.1, right, this one, okay? And 3, P 0.1, so just substitute only, 3 times 0.1, so 0.3 employees out of 3. Okay, because our N is only 3. Variance and PQ, so N is 3, P is 0.1, 1 minus P is 0.9, so we get 0.27. Okay, straight away, substitute only, quite easy, the formula. Standard deviation, you just square root the variance. So square root 0.27, you get 0.52. Actually, you don't have to rewrite like this. Straight away from here, you just square root. Okay, so we're done with binomial. Again, any question on binomial distribution before we move to Poisson distribution? Let me know if there is any example, any slides that not clear. Okay, everything okay?
Okay.
Right, let's have a 5 minutes break before we proceed with the next one, Poisson distribution. 5 minutes. Okay, can we proceed?
Yes.
All right. So next one is the second one, Poisson. Okay, it's not poison. Okay, the right pronunciation is actually Poisson. Okay, Poisson. Okay, so this one actually you can just read the Poisson distribution. Distributed random variable is often useful in estimating the number of occurrences over a specified interval of time, distance, or space. So normally for Poisson, we have this. The problem will be normally we have this specified interval of time, distance, or space. Okay, is different from binomial. So okay, it's a discrete random variable that may assume an infinite sequence of values. For example, 0, 1, 2, 3. Okay, so up to infinity. The properties, first one, the experiment consists of counting the number of times an event X occur in a given interval. Okay, the interval can be an interval of time, area, volume. So basically, it's about counting the number of times an event occur. Okay, the probability of occurrences is the same for any two intervals of equal length. Okay, these are just complete the properties. If X is the number of occurrences in a specified interval, then it's a Poisson random variable. So if you can see in the question, there is a specified interval of time, for example, then there is actually Poisson problem. You know, I mean, it's easy to identify whether it's Poisson or binomial. Binomial, the key is you only have two outcome. Okay, success, failure, like defect, not defect. That one is binomial. For Poisson problem, you can see later. You can see the example. We have a specified time, specified interval. For example, in a minute, in an hour, how many happen? Okay, in 1 hour, how many accident happen? For example, okay. So we have specified time there. There is Poisson. Okay, for example, in a day, how many calls you receive? It's Poisson. So number of computer crashes in a day, number of car accidents per month. Okay, so we have interval of time here, a day, per month. Okay, that is Poisson. Okay, so the probability is given by this formula. Okay, this is a probability that event will occur exactly X time in the given span of time, space, or distance. Okay, so that X is the event itself. So e power of negative lambda, lambda X over X lambda. What is lambda? Lambda is the expected number of success per unit. Okay, that is the expected number of success per unit, the average number. Normally also is given. Okay, in the question. E is the exponent. That one you can use calculator to find. Okay, the value is actually 2.718, blah, blah, blah. Okay, this is continuous number. Okay, let's look at the example. Suppose that on average, 5 cars enter a parking lot per minute. What is the probability that in a given minute, 7 cars will enter? So you see the difference between this one and the binomial. Right, we have this on average, 5 cars enter parking lot per minute. This is the specified interval of time, meaning that in 1 minute, 5 cars enter a parking lot. So the question is, what is the probability that in a given minute, okay, in this given minute, 7 cars will enter? Okay, so we want to find this. This is what our event of interest. So we want to find X equal to 7. The number of cars enter the parking lot equal to 7. Lambda is 5. So lambda is the average. Okay, this one. If you look at this one, lambda is the expected number, the mean. Right, expected number is the mean. Expected value. Okay, expected number. So that is the mean of success per unit, or the average number of occurrence in a specified time. So this question just now, in a specified time in this per minute, what is the expected number of occurrence is 5, right? 5 cars. Okay, so that's why our lambda is 5. So you just use a formula. Formula just now is P, this formula you can see from this slide. Okay, so it's Px E negative lambda, oops. Okay, lambda power of x over s factorial. So we have P, our x is actually 7. Sometimes we can write like this. Sometimes we straight away P7. Okay, so E power of negative lambda, lambda is 5. Okay, lambda again, 5. Power of x is 7. Over x factorial, 7 factorial. Okay, again, just use calculator. So you get the answer 0.104. Please check also whether the answer is correct or not. Okay, so what does it mean? In a given minute, because this one in a given minute, there is 0.104, or if you change to percentage, it's actually 10.4% chances that 7 car will enter the parking lot. Okay, in a given minute, only 10.4% chances 7 car is quite low actually, only 10% because 7 cars will enter. Okay, so maybe less than that, or maybe more than that, we don't know. Okay, because this one we look at 7 cars only. Okay. Okay, another example, patients arrive at the emergency room of Kampa Hospital at an average rate of 6 per hour on weekend evening. What is the probability of 3 arrival in 30 minutes on a weekend evening? Okay, try to understand the question. Patient arrive at the emergency room of Kampa Hospital at average rate of 6 per hour. So average rate 6 per hour is our lambda, right? Lambda is the expected value just now, the mean, the average number in a specified time. So in an hour, the average rate or the mean is 6. So that is our lambda. Lambda is 6 in hour. Okay, in an hour. What is the probability of 3 arrival? So we want to find this 3. This is our x. Okay, x is 3 in 30 minutes on a given evening. Okay, so it's slightly different here. Unlike the previous question, you can see that we have this 5 cars per minute. So we know lambda is 5 per minute. The question also asks in a given minute. Right, minute and minute. But this one, you can see that this one is 6 per hour. The question asks you in 30 minutes. So you have to change the lambda. Lambda here, the average is 4 per hour. So if you change that in 30 minutes, which is half of that, right? So lambda is 6 per hour in an hour. So lambda is actually 3 in 30 minutes. Okay, you have to find this first because the unit is now different. Okay, the time interval is now different. So instead of using lambda 6, we use lambda 3 and our s is 3. Okay, so use formula Px equal to 3, E negative lambda, lambda x over s factorial. So E is still E, negative lambda is negative 3, 3 power of x, so 3 power of 3, our s is 3 here, over x 3 factorial. So we get 0.224. Okay. Another one. This is a classic example. Phone call is a very famous example in Poisson. Phone calls arrive at a switchboard at an average rate of average rate of 2 calls per minute. Okay, so you can see there is a interval of time here, right, per minute. So in 1 minute, there is average call of 2. That is our lambda. Okay, so our lambda is 2. If the number of calls in any time interval follows Poisson, this one you are lucky is given here. Normally you won't mention Poisson here. Then number of phone calls in a given minute for the I think this question gives us a different time interval. Okay, just like in the previous example. So we know that in a given minute the lambda is 2. Okay, so if you look at this event, number of phone calls in the given minute, so the lambda is 2. Okay, but if you look at the number of phone call in a given hour, So how do we find that? How do we change that? Like the previous example, from hour to minute, 30 minutes, you just divide by 2 because 1 hour is 30 minutes, right? But in this case, given minute is 2. So if you want to find hour, then you have to multiply by 60 because 1 hour is 60 minutes. Okay. So per minute, 1 minute is 2. So 1 hour has 60 minutes, 60 minutes times 2. So you get 120. So your lambda is now 120 if the question asks you per hour. If the question asks 15 seconds, then it's smaller than 1 minute, right? So 15 seconds to 1 minute is just a quarter of that. Okay. So 2 times 1 quarter, 1 over 4. So it's just 0.5. Okay, so you have to know how to change. From the small to large, minute to hour, you multiply. From the large to small, from minute to second, you multiply also, but it's actually a fraction here. Okay, which actually you divide by 4. Okay, so you have to know how to change the time, the value of this according to the time interval. So the question, find the probability of exactly 5 calls. This is x equal to 5. Exactly 5 calls. We use y here, so that's method as a y. In the next 3 minutes. Okay. So in the next 3 minutes, we know from the previous question, per minute is 2, right? We know that lambda is 2. This is per minute. Okay. So if the question asks you 3 minutes, then 3 times 2 lah. So because 1 minute is 2, so 3 minutes, 3 times 2. So your lambda is now 6. Okay, so just find Py equal to 5 or Ps equal to 5, doesn't matter. Lambda x negative lambda over s factorial. So lambda is now 6. 6 power of, it's actually y here. If you use y, then this one should be y. And this one should be y. Again, doesn't matter. This one can be x also. So basically lambda is 6. 6 power of, let me write like this. 6 power of 5. 6 power of 5. E power of negative 6 over x is 5. Can you check, is it the same, this one? And my calculator is here. No, that's not calculator. Can you check, is the answer correct?
Yes.
Yeah, okay. Okay. Another example, another question. Find the probability of at least 2 phone calls in the next 3 minutes. Okay, find the probability of at least 2 phone calls. So if you look at the question, we have the word at least here. So normally we write Ps equal to 2, Ps equal to something like it's exactly. Okay. But now we know the question is at least. So at least we know, for example, at least 2 phone calls. Okay, so 2 phone calls in the next 3 minutes. 3 minutes, just now we know lambda is 6, right? Because 1 minute is 2, so 3 minutes is 6. But now, it's not just x equal to 2. The question is not asking you what is the probability that exactly 2. The question asks you the probability that at least 2. So at least 2 means should be this one, right? At least 2, it can be more than that. 3, 4, 5, 6. Okay, maximum only 6. Why is it maximum only 6? Any idea why I mentioned that the maximum is only 6? As you can see here, x is 0, 1, 2, 3, 4, 5, 6. Stop until 6 only. No 7, 8, no more. So why do you think it's only until 6? No respond. Because
of the lambda.
Okay, correct. Your lambda, your average is only 6. In next 3 minutes, you only get your average of receiving phone call is only 6. Okay, so you cannot be more than 6. So you only have either you don't receive any phone calls, you receive one phone call only, or 2 phone call, 3 phone call, 4, 5, 6 phone calls in the next 3 minutes. Okay, that's the maximum you can receive. So that's why it's this. So the question now, again, is not asking you exactly 2, unlike the previous one is exactly 5. Okay, this one is not exactly 2, but at least 2. So at least 2 means it can be 2, 3, 4, 5, 6, like this. Right? So we want this area, we want this property for this one here. We don't want property for 0 and 1 here. Okay, so how do we find? There are 2 ways actually. Either you find property of this one, you plus, so property of 2 means Px equal to 2 plus Px equal to 3 plus this plus this. So there are 5 that you have to calculate actually. Or what you do is, we know that the total probability is 1, right? Total probability for all is 1. We just don't want these 2. We want the rest. So 1 minus probability of this 0 and 1. That is easier actually. It's shorter. So if you look here, probability of x greater equal to 2 is 1. 1 is the total probability minus probability of 0, x equal to 0, plus probability of 1. Okay, you have to put bracket because minus these 2. Okay, minus this one. So then we can find what is the probability of 0. Okay, just similar to the previous one here just now. Just now we want to find 5. Now we want to find 0. All the same, our lambda is still 6. Our x here. Okay, so just substitute only in the formula. So formula just now is what? E lambda factorial. What's the formula? You need to get lambda power of x, right? Not lambda factorial. Lambda power of x e negative lambda over s factorial, right? So lambda is 6. Lambda is 6. 6 power of 0 because your x is 0 here. E power of negative lambda, so e power of negative 6 over 0 factorial. Okay, this calculator you get 0.002479. And for probability of 1, so you just substitute your x by 1 only. So lambda is still 6, 6 power of 1. E negative lambda, so e negative 6 over 1 factorial. Okay, that one is. So what you do is 1 minus probability of these 2. Okay, so 1 minus this. So you get the answer. It's just the same as, another way is finding probability of 2, Px equal to 2 plus probability Px equal to 3 plus probability x equal to 4 plus probability x equal to 5 plus probability x equal to 6, which is more tedious, right? So you have to find 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 5 instead of 2. Here you only find 2. So 1 minus this 2. Okay. Another way is to find each of these because we know greater equal to 2 is 2, 3, 4, 5, 6. So probability of this one plus probability of this, which is longer. Okay, so you don't want to do that, then just 1 minus that. Okay, so it actually depends. If the question, for example, asks you probability of, let's say, at least, probability of at least more than 5. So probability of at least more than 5 is just probability of 5 plus probability of 6, right? More than 5 is only 5 and 6, these 2. So if only these 2, then better you calculate 1 by 1 like this instead of 1 minus the rest. Okay, because it's more work to do if you minus all this one, right? So it's easier find probability of this plus probability of this. So it depends on the question. Okay, you have to look at the values. That's why it's better for you to write or draw something like this so you can see, okay, what values you want, which value you want. Okay, so that's similar to binomial. You also can find the mean and variance standard deviation for the Poisson. Okay, this one is simpler because the mean is actually just the lambda itself because lambda just now based on the definition is average, right? So that is the mean, the average, okay, the expected value. And the variance also lambda. The standard deviation is the square root of variance, the square root of lambda. So it's quite easy. Mean lambda, variance also lambda for the Poisson. Okay. For binomial just now, NP and NPQ, right? So this one is on both lambda. Okay, so there's no example for this one. Okay, any question? We're done with this topic. Any question? Anyone? Is this example clear? Okay, yeah. Responsible now.
Okay, doctor.
Okay.
Right. Okay, great. So we're done with this, so we can proceed with the tutorial. So tutorial on probability. The first group to pre. I hope all are here. Pasana group. You can share your slides if you have. So while waiting for that, any of you are encouraged to ask. Okay, if you don't understand or you get different answer, just ask the question. The group who present also can ask any question to the to any of you, to the rest. Okay, you are welcome to us. It's a in good interactive way. So it's two ways, not just one side present, the rest maybe sleeping or eating or doing something else. So we want both side to engage in this. Okay, so the first